Hello. Today or tonight, it's the 9th of December. We're going to look at the area of a triangle. In the past, we did 1/2 times the base times the height was the area. I'll say triangle's area. Triangle symbol area. So, looking at the area of a triangle as 1/2 base times height is old news. So tonight, we're going to look at two other ways to look at that. The triangles that we're looking at are oblique. They have no right angles. Oh, how bleak. And here is what we're going to discover. Let's draw one that has some size to it. Notice there are no right angles in this triangle. And I'm going to call them the ABC. ABC, and I'm going to drop a height from angle C to side C, calling it H. Now, looking at that, I can see that the sine of angle A, from this perspective, opposite over hypotenuse, is H over B. Solving that for B, I get B sine A equals H. And we've been using that idea for some other things. So, how will that work if I put it in the area of a triangle formula, 1/2 base times height? So the triangle's area equals 1/2 base times height. Well, in our oblique triangle here, we still have the 1/2. And what is the base of this triangle? It is side C. And what's the height? It is B sine A. So I just rearrange the B and the C for aesthetics so it looks nice. And I have one of my new formulas for the area of a triangle. 1/2 BC sine A. I'll give you the other two forms, and those are copycats of this. It's just that we're going to use different angles. So if this is angle B, this will be A and C. So I'll write 1/2 AC sine B. And there's one left, and that's going to be 1/2. And now I'm going to use sine C, so it's going to be AB sine C. You see this one most often in textbooks, but all three of those, depending on what sides and angles are given in your triangle, all three of those are useful. So let's do one. So it's trying to keep those in the screen. Suppose we have a triangle that looks like this, ABC. And side B is 52, side C is 90, and we have this angle. So what is the area of that triangle? So since I know sine of angle A, since I know angle A, I'm going to use the one with sine of A in it. So I'm going to have area of a triangle equals 1/2 BC sine A. So nothing to it. Put in the B is 52, and the C is 90, and the A is 102. Come back, come back. I get, when I tap that all in the calculator, I get 2,289. 2,289. And if these were meters, we'll say they were meters squared because it is an area. All right, easy peasy. All right, there's another way to do that, and sometimes we don't have an angle, so we have to use Heron's formula and his area formula. And he noticed that if you don't know any angles, that you can still get if you know all three sides and no angles, you can still get the area by using his formula. And So let's give ourselves a triangle with no sides known. So we'll say here's A, B, and C. I'm sorry, no angles known. And say A is 43 and B is 53 and C, excuse me, C is 72. Excuse me. Then his formula will make use of the A, B, and C in this way. S times S minus A times S minus B times S minus C. The question is, what in the world is S? So he came along and told us it's the sum of the sides divided by 2. So if you get that first and put it in for S and all these values in for A, B, and C, you just plug it in. So let's just do this one since we are very curious as to what its area is. Now we could use the law of cosines and come up with an angle and then go back to the method up here. But we have Haran's formula, so we want to use it. So let's figure out what S is first. So if we sum A, B, and C, what's 53 plus 43 plus 72 divided by 2? I got 84. And then I just plug it in this formula. S is now 84 times 84 minus A, 43, times 84 minus 53. See, I'm just plugging in appropriately. 84 minus 72. All right. So coming out with all those, let's see what's the square root of 84. 84 minus 43 looks like 41. I don't feel like searching for my calculator, but I guess I'm gonna have to. 31 and 12. All right, so when I multiply that and take the square root, do I not get something around 1,131.89? If this is meters, some unit, meters squared. All right, short and sweet. What a treat. All right, I'll see you tomorrow. Have a good night. Bye-bye.